Good morning, everyone. Welcome to our talk on deep learning microservices. I'm Karthik,
And I'm Brendan Dwyer.
and we are software engineers and data scientists at the IBM Center for Open Source Data and AI Technologies. A little bit about our team. We are relatively new, about 2 years old. We work on all things open source data and AI. Our aim is to make AI solutions easier to create, deploy, and manage in the enterprise. We have mix of engineers, data scientists, and developer advocates, working on open source projects, contributors and committers, etc. We work on a bunch of projects across the whole data science pipeline. So we have projects like Spark, we have our own projects, and we also contribute to TensorFlow, Keras, PyTorch, etc. So as you can see, we work a lot on the whole data science area. A little bit about what data science is, and a part of it that we will be covering today. So the goal is to find the solution to a business problem by transforming it into well-posed questions, and then we use programming, mathematics, the scientific method, and then finally we communicate the results and its business impact, right? So that's the whole a functional level overview of data science, a very broad functional level overview. When you translate it into a more technical level, it includes steps like data extraction, data cleaning, data exploration, model development, and result interpretation. As you can see, there's a lot of steps to do with raw data and playing around with data. That's a big part of all projects, and it's really important. But today we'll be focusing more on the model development part. Although it's just one of the 5 steps here, it's like kind of the whole quote-unquote solution when you talk about a data science solution. Traditionally, there have been a lot of rule-based and statistical models that have been deployed, but there's a new trend emerging that's called deep learning. Just by a show of hands, how many here have heard of the term deep learning or come across it? Okay, yeah, that's a good number. And how many of you have actually built an application or trained a model or deployed it, even in production at your own companies or labs? Okay, so that's far lesser. So that's because it's still, it's still in a more research-heavy phase. There are a lot of things to be done before it can be taken to production. A quick overview, so deep learning is machine learning with large deep neural networks. It's actually not a new concept. It's been around for almost 50 years now. It has its root in neuroscience and basically tries to emulate the way we think. Our brain processes signals and produces outcomes. So you can see on the left is like a visualization of neurons in your brain, and on the right is a simple neural network trying to classify a dog or a cat. So you can see there are some inspirations there. And it's called deep learning because this is a very small network, but typically you would have a much larger and a bigger network, right? So like I said, it's not new. It's been around for a while, but the reasons why it's so popular now is that there is access to huge amounts of data. So companies are collecting more data than they ever did. A lot of us are using more of the services, and then we are giving more of the data, etc. We also have made advances in computational efficiency and memory and GPUs, etc. So there's the reason that it's getting more and more popular, right? So we'll start with a simple example of object detection. It's easy for us to perceive this, but as a computer, perceiving images and object detection is a really, really hard task. It's not easy, as easy as it's not trivial by any means. So if you were to build, hypothetically, an object detector model from scratch with not much background in the field, simple Google search would be a first step, right? And then when you search, even Google Scholar or Google search for object detector, you see there's like tons of results, all of them in peer-reviewed publications. There are a lot of citations, etc. All of them look like good options. So how do you decide? What do you do next? As a beginner, especially in this field, so there's like an information overload out there. So the first step you always do is you find a model that does what you need, which is free to use. And free here means commercially reusable. We are all talking about enterprise data science. So something on an Apache or like an MIT license that is performant enough. So that does actually your task at hand, right? The next step is you get the code, clean up So a good thing about research in this field these days is that a lot of authors are kind enough to open source the code that goes along with the models. But there's still a big difference between research code and production code, right? So there's a step that is crucial there. And again, it comes back to whether it's commercially reusable. If it's not, then you have to write your own code to reproduce the model and the results. The next process is to train. So as some of you have already trained a model or used a model, you might be familiar that there are multiple frameworks, multiple languages, and then when you do it on device, it's different. When you do it on the cloud, it's different, etc. And then I'm assuming if you're using this for an enterprise use case, you have your own data. But in cases of transfer learning, or in case you want to use a pre-trained model, there's again the whole aspect of data license, and if the data was commercially reusable, and if the model is a quote-unquote derived work that can be reused, right? And then finally, if you're able to do all of this, the next step is to actually deploy it and then consume it. So most of the deep learning models are computational graphs. So they have a different, code for training and a different code for deploying it or performing inference. So you need to repackage your whole code into a more scalable fashion. So as you can see, this whole process is cumbersome to say the least. It requires time, expertise, and resources. And again, within your own companies, you might be either a developer or a data scientist, so you'd have different goals, right? So as a developer, would you want to learn deep learning to make an application and worry about like the engineering aspects of it, or as a data scientist, you focus more on training the model and picking a model, and all in all, it's like there's the breadth aspect to this as well, not just the depth. So we, as data scientists and developers, have built a project that hopefully makes this easier to adopt deep learning in the enterprise. And Brendan here would like to show you how.
Sure. Thanks, Karthik. So that's the problem. And to solve this problem, our team at IBM, we worked on a project called the Model Asset Exchange, or MAX for short. MAX is a completely open source repository of state-of-the-art deep learning models, and we vetted them all to make sure that they can be run in an enterprise. All the code in it is enterprise friendly. The weights are enterprise friendly. You can use this in production. All these models are wrapped neatly inside inside containers with a consistent REST API. You can run these locally. You can run these on IBM Cloud, on any cloud, anywhere that you can run containers. You can run these models. It's super easy to get started with these Max models. All you have to do is run one command in Docker, and it'll automatically download and run these models on your computer. And you can get started in less than 5 minutes if you have sufficient bandwidth to download these. Our team, when we make a Max model, we start by finding state-of-the-art deep learning models, or sometimes creating our own if there isn't a model that exists for the use case we want. Then we verify the license terms to make sure that you can run these in an enterprise. We then train the models and create inference code, or use existing code and weights if it's enterprise friendly. Then we wrap the models inside containers using a Python package we created called Max Framework that provides a consistent REST API. Then we publish these models on GitHub and DockerHub, and we're always running continuous integration to check the model quality and make sure that software updates don't break anything. Here's a very simple diagram of how Max works. On the left side is everything you're running inside a container, and on the right side is your application. As you can see, you don't need to understand deep learning at all. If you can call a REST API, you can use deep learning in your application. Here's the Flask interface to one of our models. For this model, you can see there are 3 callable APIs. The labels API here returns labels that this model can return. For example, this is object detector, so that could be all the hundreds or thousands of different objects that this model's been trained on. The metadata API included with all models contains specific information about this model, like the license, the input, the output. And finally, the predict API allows you to upload or submit an image and run inference against the model. Here's one of the web pages on the Model Asset Exchange. On the right side, you can see we have a link to the GitHub repository, an online demo that we host on Kubernetes, so you can play with this model just using a web browser. A web app that our team created to show you the power of using one of these Max models. It's an app that I think just you upload an image and it'll, in your browser, do all sorts of cool stuff. And finally, instructions if you want to run this model in Node-RED. This specific model also supports ARM CPUs, and that's really cool because you can run this on something like a Raspberry Pi or lots of IoT embedded devices. A few of our models support ARM, and in the future we hope to have some more. So far we showed you what we did, but if our catalog isn't complete or sufficient and you need to deploy your own proprietary model, here's how you'd wrap your model with the same API. Max Skeleton is a template GitHub repository that you can use to start wrapping your own model. And Max Framework is the Python package that abstracts all the basic functions to Max so that all the models have consistent API. All of this and our other code is all open source and can be found on GitHub. And there'll be a link to that at the end. Real quick, I just want to show you a quick demo of getting started with Max. Can you see it? So, like I said, you just have to call one run command to get Max started locally. In this case, I'm using Docker run -it. Then you have to map a port to it. All of our models use port 5000, code 8/max. In this case, I already have the model. In this case, I already have the model downloaded locally, so it's just going to run from my device. But if I didn't, Docker is smart enough to automatically go online from DockerHub and pull this. So with that one command, I can open up my web browser on port 5000, and I have the object detector model running. And these are the interfaces I told you about in my earlier slide. For example, I can get a list of all the different things this model can return. And the metadata. As you can see, this is an Apache 2 licensed model, which is typically fine for most enterprises. And then finally, the predict API. I'll try it out with. We provide some sample images. So here's just a picture of, you can't really see it, but it's just a kid sitting next to a teddy bear on, looks like a wooden bridge. And we can set a threshold of the confidence we want the model to return. So in this case, anything above 70% confidence will be included in the result. And it takes a second. So in this case, it returned the teddy bear with the 98.9% confidence, and it created a detection box so we can see where in the image we think the model thinks the teddy bear is, and it returned a person. We have a bunch of different models. Oh, not connected to the internet. A wide variety of models, and we're always adding more. And if there's anything that's missing, you can go into our GitHub repositories, and if you think you want to contribute a model, we're always open to that. We do have a way to thanks. Unfortunately, we don't have time right now to talk about IBM Cloud Functions, but our Max models do work with IBM Cloud Functions. We have a link if you want to learn more, ibm.biz/maxserverless, which is a tutorial on how to deploy these models in IBM Cloud using our function service. But this is in no way restricted to just IBM Cloud. You can run this locally or anywhere that supports containers. And finally, some resources that I promised. Our Model Asset Exchange, the GitHub repository. A lot of our stuff is either under the IBM organization on GitHub or code 8, CODAIT. The serverless tutorial and a Model Asset Exchange learning path. Yes, and finally, if you want to see our slides, it's kind of small, I don't know if you can see it, ibm.biz/serverless NA 2020, and that'll take you to see our slides. Karthik and I will be available in the back if anyone has any questions, and thank you for coming.